Oh, hey guys. Just sitting here minding my own business. Whoa! Did you feel that? I felt that. I think we just had an earthquake. Well, it's a very good thing that I am quite rich and I have several highly sophisticated seismographs located in stations around the country. I'm gonna go grab that data and let's see what we can find. Wow. This is some really interesting data. I think I can use this data to triangulate exactly where the earthquake occurred. And maybe we should do this together. So come on.
If you can remember from what we talked about in class, seismographs record the vibrations felt in the ground, and the readouts look like this. As you can see in these recordings, someone has been nice enough to label the beginning of the P and the S waves already. And they correctly remembered that the P waves are the first to arrive, followed by the S waves. Below the readouts, there is a timetable, so if you take a ruler to help you mark your intervals, you can find out what the time difference is between the beginning of the P waves and the beginning of the S waves. I'm just going to use different colors to help me recognize which set is which. You don't have to do this step, it's just something that helps. If we look here, the interval for station 1 is from about 420 seconds to 450 seconds. So the difference between the P and the S waves is a 30-second interval. For station 2, it goes from about 432 seconds to about 482 seconds, which is a 50-second interval. And station 3 goes from about 440 seconds to 500 seconds, which makes it a 60-second interval. Now, continuing to fill out this table, we multiply each number by 8 because the difference in wave speed between P and S waves is about 8 kilometers per second. These distances represent that the earthquake could have occurred anywhere within a 360-degree circle at that distance from the station. You transfer all of your information over to the next table. And in order to convert these distances to our map, we need to divide each number by 150 because 150 kilometers is equal to 1 inch on our map. I've gone ahead and done these calculations already, and I'm going to round up to the nearest tenth. And if you think it'd be easier to convert over to centimeters even further, just multiply your number of inches by 2.54 and round to the nearest tenth. So, next step, set your compass to the correct measurement for a particular station and create a circle around that station like so. Continue this for the next steps. As you can see, my circles weren't perfect, but that's okay. Now that we have all three circles drawn up, we can see that they all intersect at about this point right here. This is the location of the epicenter of the earthquake. 240 kilometers from Station 1, 400 kilometers from Station 2, and 480 kilometers from Station 3. Isn't that just so easy?
Alright, now you know how to locate the epicenter of an earthquake, if for whatever reason you ever had to. Like right now, in fact, because you're going to have to fill out 2 more triangulation exercises in that nasty looking packet I gave you in class the other day. And don't forget to complete all of the questions that follow up the exercises, and this whole thing will be due on Wednesday the 9th. So good luck, and we'll see you in class.